thing that I want to point out to you is how is this chapter different from chapter 7? And it's because in chapter 7, I don't know if anybody noticed, but it was kind of weird and counterintuitive. We pretended to know about the population, and then we were asked questions about what could happen in a sample. Well, that's not really the natural way things work. So chapter 7 was a little bit backwards. We pretended to know the truth about a population, so it would give you like it would give you the population percentages or the population means, and we were asked questions about what could happen in a sample. What could happen in a sample? This chapter is more realistic. We're going to begin with information about a sample, and then that will let us answer questions about the population, and that's the nature of statistics. So we begin with information about a sample, and ask questions about the population. So the top of your notes, the title here is the idea of confidence intervals. This chapter is going to be about making estimations about the population with confidence. And then again, you've seen this before. We use statistics to help us estimate parameters. So let me jump down here to what is a confidence interval. It's an interval of plausible, think like possible, plausible values for a parameter, an interval of plausible values for a parameter based on sample data. It's an interval of values that the parameter could be in. Confidence intervals are constructed so we know how much confidence we have. So you're going to see some percentages. It's called the confidence level. The most common ones are 90, 95, and 99% confidence, but you could really see any percentage in there. And I'll teach you how to deal with that in the future. But you're going to be asked two different types of questions, and you need to kind of keep these straight, and they can be confusing. You're going to be asked to interpret a confidence interval, and then in a little while you're going to be asked to interpret the confidence level. They're completely different as far as the sentences that you would need to write on an AP exam. So if you're given an interval of values, or you calculate the interval of values, and you are asked to interpret the interval itself, then here's your little sentence stem. You will write, we are whatever percent, like 95% confident that the interval from blank to blank captures the true, and then your parameter will go in context. So we're going to practice that right now. In this problem right here, it says a large company is concerned that many of its employees are in poor condition, which can result in decreased productivity. To estimate how many steps employees take per day on average, the company provides a fitness tracker to 50 randomly selected employees to use for a month. After collecting the data, the company statistician reports a 95% confidence interval from 4,547 steps to 8,473 steps. Interpret what that interval means. Interval. So we're going to use that sentence stem right up there in that box. But before we do that, I just want to ask you, if you want to jot these down, you can. Let's review some words here, some vocab words. What is the population of interest here? What's the population? It's going to be all employees at the company. What is the sample? 50 randomly selected employees. Good. What would the parameter be? I'm going to go ahead and write that one down. Parameter. What's the parameter of interest? What are they interested in knowing about all the employees of the company?
Average steps per day.
Good. The average or mean daily steps. Average daily steps of all employees. And so then what is the statistic that they're going to use to estimate that?
Average steps for 50 randomly selected employees.
Yeah, it's the same exact information, but it's just about the sample of 50. So the statistic is going to be, bless you, the average daily steps of the 50 in the sample. So don't overthink it, but keep your parameters and statistics straight in your mind. So let's actually write the sentence stem for interpreting a confidence interval. All right, we are 95% confident that the interval from 4,547 to 8,473 captures the true mean daily steps of all employees. This is your parameter in context. The mean daily steps of all employees at the company. So interpreting intervals will always be written like this, and I think that by the time you take the test, you guys will be pretty good on that. Really fast, I want you to know, sometimes confidence intervals are written like this. The lower, the upper, it almost looks like an ordered pair. So if we were looking at this problem right above there and we wanted to write the confidence interval like that, lower boundary, comma, upper boundary, we would just write 4,547 steps, comma, 8,473. Just in case you see a confidence interval written like that, I want you to know that's what's going on. All right, turn the page. I think this graphic is really important to just kind of give you a visual of what a confidence interval is. There are two things that help create a confidence interval. Something called a point estimate. And in your picture, the point estimate is right smack dab in the middle of the interval. Point estimate is always going to be right in the middle of the interval. It's a midpoint, if you will. And then something called a margin of error. The margin of error tells you how far to the left, and if you're looking at this as a number line, how far you would subtract or add to the point estimate to get your actual values of the interval. So the margin of error is going to tell you how wide your confidence interval is. So these little arrows just kind of emphasize that. And then the brackets themselves are just to show you that that's where the interval would actually be, from here to here. Point estimate is in the middle. The margin of error tells you how far you're going to subtract and add to the point estimate to get your lower and upper boundaries of your confidence interval. All right, so we've got this question here with parts A, B, and C. What proportion of American adults think it's okay to post spoilers about a new movie on social media within 48 hours of its release? According to Morning Consult poll from October 2020, A 95% confidence interval for the proportion of American adults who think it's okay is 0.34 to 0.38. Interpret the confidence interval. That's where we're going to write our sentence stem again, so we get a little bit more practice with that. We are 95% is what it says up here. That could be any percentage value, so it's not always going to be 95, but 95 is pretty common. We are 95% confident that the interval from 0.34 to 0.38 captures the true proportion of American adults that's why you have to be really good at spotting what the parameter would be. The proportion of American adults who think it's okay, and I'm just going to put ... so you don't have to finish that out. Because technically you would need to write, who think it's okay to post spoilers about a new movie on social media within 48 hours of its release. I don't want to write all that. B is going to require a little bit of math. I think you'll find this pretty easy. If we have the lower and upper ends of our boundary, we have 0.34 to 0.38. Calculate the point estimate. In other words, calculate what would be right in the middle, and then the margin of error. So if I go from 0.34 to 0.38, what would be in the middle of those two values? Yeah, so 0.36 is the point estimate. Margin of error is just from the middle down to 0.34 or from the middle up to 0.38. What's the difference there? Yep. Oops, and let's write MOE. That's how you'll see it abbreviated sometimes, is MOE, margin of error is 0.02. And I think you even have a test question that's that easy. A little bit of math, but here's two numbers. Find what's in the middle. Find the distance from the middle out to one of the edges. C, is there convincing evidence that less than half, these questions are kind of weird until you get used to them. Is there convincing evidence that less than 50% of Americans think that it's okay to post spoilers? Well, what we have is we have a confidence interval. What this tells me is that we're pretty sure that somewhere between 0.34 and 0.38 Americans think that it's okay. So is that evidence, is it convincing evidence that less than 0.5 of all American adults think it's okay? What do you guys think? It's probably easier than you guess. Does the interval have 0.5 in it at all? No. Does the interval include anything above 0.5? As a matter of fact, every single decimal value between these two numbers is less than 0.5. That means that, yes, there is convincing evidence. Yes, there is convincing evidence. And I'm just going to put, because all of the values in the interval are less than 0.5. Now, if that confidence interval went all the way up to 0.51, then there actually would not be convincing evidence, because this is just saying, I'm pretty sure that the population lies somewhere between here and here. So if that went all the way up to 0.51, then we wouldn't have convincing evidence, because technically the parameter could be, I don't know, 0.52 or something like that. All right, turn the page. Now let's talk about level. What does that 95% really mean that keeps showing up? Level. I've shown you how to interpret the interval itself, but the level is like the 95%. You'll see like 90, 99%. The percentages that show up in the word problem, how do we interpret what that means? It's pretty abstract. So I went ahead and just put it in your notes so you didn't have to write it down. What it really means is the overall success rate of the method used. For example, and I just really liked the way this was put by another teacher, about 95% of 95% confidence intervals will capture the truth. That's really what it means. About 95%, so if you created a bunch of confidence intervals from a bunch of different samples, about 95% of them would capture the truth. So how do you interpret a confidence interval? Excuse me, a confidence level. We can underline it there. What does it mean to be 95% confidence? So let's write this down. If we took many samples of the same size from the same population, if we took many samples of the same size from the same pop, and construct a confidence interval, I'm going to put and construct a C% confidence interval from each sample. So I take a sample, I construct a confidence interval. I do that again and again and again and again, and I make them all 95% confidence intervals. Comma, about 90, or let's put C% again. It could be any percentage. About C% of the intervals would capture the truth. So just be really careful, even on a multiple choice question, if it's asking you about interpreting the interval versus the level. Confidence interval versus confidence level. So we're going to just take that spoiler alert example, which had 95% in it, and interpret what that means in context so that you have a little bit of practice with that. Okay, this is not really fun to write, but I'm going to go ahead and just stick it up here. It's the purple part right here. I'll read it out loud, so if you want to just write, this is what it says. If many samples of the same size, were taken from U.S. adults and a 95% confidence interval was constructed for each sample, a 95% confidence interval, and you can abbreviate confidence interval by writing CI. 95% confidence interval was constructed for each sample. Then about 95% of those CIs would capture, and then in context, the true proportion of American adults who think it's okay to post spoilers, ... That's what the level tells us. If we did this a whole bunch of times, about 95% of those confidence intervals would capture the truth. I'll go ahead and write the next part. As a statistician, do you prefer a small or large margin of error? Well, you prefer a smaller margin of error because that means that your confidence interval is going to capture the truth better. It's going to be closer to the truth. So let's go ahead and start by writing that. I want you to understand that we prefer a smaller MOE so our estimates are more precise. Here's an example. If the weatherman said, today's high is going to be somewhere between 0 degrees and 100 degrees, is that a large or small margin of error? It's a really big margin of error. And is that really helpful to us when we're trying to figure out what we're supposed to wear that day? No. Okay? So I would really prefer the weatherman to give me a small margin of error, like the high is going to be somewhere between 85 and 90. Then I know, oh, it's going to be warm outside and I can dress accordingly. But the trade-off is, so it says, how can we reduce the margin of error if that's what we want? The trade-off is you have to decrease your level of confidence. You have to decrease the confidence interval. If you want a smaller margin of error, you have to use a smaller confidence level. All right, so let's just put the trade-off is a decrease in confidence level. What I mean is, if the weatherman said the high is somewhere between 0 and 100 degrees, I'm not 100% sure that's going to be accurate. But when he narrows it down to between 85 and 90, now he can't really be as, the confidence level has to decrease just a tad. He can't be as confident, excuse me. So the trade-off is your percentage, your confidence level goes down. There are all different kinds of multiple choice questions I see about those and how they're related, okay? The other way that you can, the really easy way to create a smaller margin of error is with a larger sample size. You could increase sample size. And you might be thinking, well, then why wouldn't you just do that? That sounds a lot easier. Well, in the real world, increasing your sample size usually costs a lot of time and money, so sometimes it's not feasible to do that. So sometimes you might have to just decrease that percentage from, let's say, 95% confident down to like 90% confident. And then this is a very easy question to ask down here, and I have seen a test question. You may even have one on a quiz about this. Does the margin of error account for any sort of bias? Like the way that you collect your data. Oh, you have people who didn't respond, or you have a poorly worded question in your survey. Does the margin of error account for any of that? No. So you might have to go back to the drawing board then. If you're thinking that that margin of error accounts for any sort of thing that's bad that happened in the data collection, it doesn't. So you might have to go back to the drawing board and collect your data in a better way if that's the case.